Day 74 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time at day 74. Hope you guys are excited to keep learning and keep doing some more LeetCode. And hope you guys are still staying motivated and staying disciplined as well, guys, because that's what it's all about. There's no end game in sight, really. Even after getting a job, you're still going to have to practice and keep up with your LeetCode so you can stay sharp and you can stay ahead of the game. So there's really no end date or end game to this. We're just going to keep going and going like the Energizer Bunny. We don't stop, guys. Now, with that being said, don't forget, bring a mouse right over here. Right over here, and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, go ahead into the comment section. I'm calling all of my bankers to the comment section. I need you to drop 2 bank emojis in that comment section so we can run up this engagement and we could bring more Swift awareness to a broader audience, and we can help grow the Swift community together, just like we're learning together, guys. Now, with that being said, I know why you're here. You're here for the question and the part you've all been waiting for, guys. The drum roll, please. Today we have question number 746, minimum cost of the climbing stairs. The difficulty level is easy, so you know how we do. We're not going to make the solution harder than it needs to be. We're going to keep the solution as simple and easy to understand as possible so we all can understand what we're learning, or so we all can learn and we all can understand what it is that we're learning, and we all can gain something from this video today. So let's see what the question says. It says you are given an integer array cost where cost I is the cost of the ith step on the staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from the step with index 0 or you can start with index 1. Return the minimum cost to reach the top floor. So let's break that down and see what it is that they want us to do exactly. So let's look at example 1. In example 1, it says we have our input cost, the array of integers 10, 15, and 20. The output is 15. The explanation says you will start at index 1 and then you will pay and climb 2 steps to reach the top. The total cost is 15. So let's break that down and see what it is that they're talking about. So first it says right here, it says you can either start from step 0 or with step index 0, or you can start the step with index 1. In this case, we want the minimum cost. So if we start from index 1, we could just pay that once, we could jump 2, and now we're at the top of the staircase, because up here it says once you pay the cost, you can either climb 1 or 2 steps. So we're going to choose index 1. We're going to start with index 1. We're going to pay that 15. Then we're going to climb 1, 2 steps outside of the array, and that represents the top of the staircase, or the top floor. If we would have picked 10, then we would have to pay either way. If we would have started with index 0, we would have had to pay twice, because we could either go 1 or 2 steps. So if we went 1 step, if we paid 10 and went 1 step, we'd have to pay another 15. We'd be at 25. If we paid 10 and went 2 steps, we still have to pay this 20, and that would equal 30. So we want the minimum cost, which is why we started on index 1, because if we start on index 1, we just have to pay this 15, take 2 steps, and that's all we have to pay, and we're at the top of the staircase. So let's look at example 2, because there's a little bit more inputs and a little bit more elements in the array, so we can really understand what it is that they're asking and what it is that they want us to do. So in example 2, they have the input, the cost, they have the list of the integers in the array. The output is 6. The explanation breaks it down. You will start at index 0. You will pay 1, climb 2 steps, pay 1, now you're index 2, pay 1 and climb 2 steps to reach index 4, pay 1 again to climb 2 steps and reach index 6, then pay 1 and climb 1 step, and now you're index 7. Then you pay 1 and climb 2 steps and reach index 9. Then you pay 1 and climb 1 step to reach the top of the staircase, and the total cost was 6 because we paid 1 6 times. So let's break that down right here so we can see what it is, because remember, we want the minimum cost. So in this case, we already know we're not trying to pay $100. You could either pay $1 or we could pay $100. And we want to pay the minimum amount of dollars. So we're going to start with this 1 at index 0. So we pay this 1. This 1 allows us to jump 1 or 2 steps. If we jump 1 step, we're going to have to pay that 100. But if we jump 2 steps, we only have to pay 1. So we're going to pay this 1 and we're going to jump 2 steps into index 2 like it says right here. So we only have to pay 1 step again. $1 again. So now we have $1 to pay. We pay this $1. We could either go 1 step or we could go 2 steps. We're going to go 2 steps since they're both $1, and the second step is going to get us closer to our goal. So we're just going to pay this dollar right here and take 2 steps. Now we're at index 4, right? So now we're at index 4. We pay this dollar. We have the opportunity. We could pay $100, or we could take 1 step and pay $100, or we could take 1 step and then have to pay $1. And remember, we want the minimum, so we're going to take the 2 steps and we're going to pay this dollar. Then we're going to take 2 steps over this 100, and we're going to land right here on this one right here, index 6. Now we could pay this dollar. We pay this dollar again, and we can either take 1 step or we can take 2 steps. If we take 1 step, we're going to have to pay $1. If we pay 2 steps, we're going to have to pay $2. Since we want the minimum, we're going to pay one. We're going to take 1 step, so we only have to pay $2. So we only have to pay $1. Excuse me. So then now we're right here, index 7. So now we pay this dollar. We could take 1 step and have to pay $100, or we could take 2 steps and pay $1. And since we're trying to pay the least amount of money, we're going to take 2 steps and pay, so we land and only have to pay $1 more, and now we just pay this $1, and then we at the top of the staircase. So that's how that works, and that's why we when we add up all these dollars that we had to pay, it comes out to $6. We had to pay $6, which is the minimum cost that we could ever pay. So, and that's what we want, the minimum cost possible. So 6 would be the minimum cost possible, and that's what we want. So now that we know what the question is asking, let's figure out how we're going to code it. And the code's not that hard, guys. It's not even that many lines of code. We should breeze through this code real easy, especially if this isn't your first time on the channel and you've been keeping up with the channel. So the first thing we're going to do is we're going to come, excuse me, guys, and we are going to declare a variable called n, and we're going to set that equal to, we're going to set that equal to cost.count, and that's going to represent all the steps that we need to take, all the steps in the staircase. Then, but it's really all the elements in the array, but for the sake of the question, all the steps in the staircase. Then we're going to come down here, we're going to declare another variable called min cost, and we're going to set that equal to an array. And that array is, this is just going to be like a default array. It's going to be an array of repeating zeros. So we're going to say repeating 0, and count is going to be n plus 1. And remember, it's n plus 1 because we're trying to get to the top of the staircase outside of the array. The top of the staircase, we can't see it. It's not included in the array. So we have to get all the way out of the array, which is why we're saying n plus 1, because that's what we're trying to get to. Then we're going to come down here. We're going to declare another variable called I equal to 2, just in case we want to start on the second index, or the first index, I should say, on the second step, just in case we want to start on the second step. Then we're going to come down here and we are going to say, while I is less than or equal to n, we are going to say min cost I is equal to min. Then we're going to open up our brackets, and we are going to, we're going to open up our parentheses, and we are going to say min cost I minus 1 plus cost I minus 1. And that's going to, or let me finish, let's finish this part first. So then we're going to say comma, then we're going to say min cost I minus 2 Then we're going to come over here and say plus. Then we're going to say, no, excuse me. Then we're going to say cost I minus 2. So this is going to check to see if this is going to find the minimum of, we're going to see if it's cheaper to take 1 step or if it's cheaper to take 2 steps. And it's going to return the minimum of whichever one is cheaper. So then after we do that, we are going to come down here and we're going to have to increment I so we could go on to the next one. We're just going to say I plus equals 1. And then we are going to come down here and we are going to say return min cost n. And that's all she wrote, guys. That's all we really had to do. So let's run it and see how it runs. Fingers crossed, fingers crossed. Let's see, and it's accepted, guys. So let's submit it. Let's submit it one more time. See what it says. Boom, and it's accepted, guys. 8 milliseconds beats 84.24% of users with Swift, guys. That's what I like to see. Let's keep it going, guys. Let's keep up with this coding journey so we could get these jobs and we're not any brokies out here. We don't want to be the brokies out here, guys. So we're going to have to keep learning and keep coding so we could get a good job. Now, with that being said, guys, I hope to see you guys tomorrow for another day, another LeetCode problem. Peace.